Okay, so we got the next topic, which is problems dealing with scalene or oblique triangle. So these are triangles that doesn't have any equal sides. Okay, so let's go for number one. Let me change. Okay, for number one, so we got a tower casts a shadow of 15 meters long when the angle of elevation of the sun is 61 degrees. So if the tower has leaned 15 degrees from the vertical towards the sun, so what is the length of the tower? Okay, so we will be let's say that this is the shadow. Okay, so I'll try to make the figure bigger. Okay, so let's say that this is the shadow. Okay, and if that's the shadow, then we got here a, so the sun must be somewhere here, right? Let's say maybe here. Okay. Let's say this is the sun. Okay. Okay, so that's the sun. And then I'm sorry, I'm not really good at drawing, so I'll just I hope you still get the idea. Okay, that's the real important thing, that you get the idea. And then, so if this is the ground shadow, okay, so this one is the ground shadow. This is, how long is this one? This is 15 meters long. And then when, so 61 degrees, and if the tower has leaned 15 degrees, so let's say that this is the vertical, right? Okay. Okay, so this is the vertical. So this is the tower. So it is leaned 15 degrees. Okay. So it should be something like this. Okay. Maybe I can make it longer. Maybe something like this. There we go. So this is 15 degrees. Okay. So this is 15 degrees. And then, so this is the ground shadow up to this one. So this will be your angle of elevation. So angle of elevation, 61. Okay. So this is 61 degrees. We're looking for this one, this x. Okay. I think for this one you can just use what you call the sine law. Okay. So this is 90, right? So this is 90. And we all know that let's say that this is beta. Okay, this is beta. So we all know that the total angle of the triangle, it should be 180. Therefore, we can say that beta is equal to 180 minus 61 minus, that's 90, right? 90 plus minus 15. And then I think this will be equal to this one. So 180 180 minus 61, 90 minus 15. That's 14. We got 14 degrees. Okay, and then with that we can just use sine law. Okay, sine law. So using sine law, the opposite angle and the opposite side, so that will become x over sine 61, right? And then beta, so sine beta, or 14, it should be the opposite side is 15. Okay, 15. And then all you have to do is just compute for x, and then the value of x will be 54.2295 meters. So this will be your answer. So let's get to the next problem. Okay, so we got our second problem. So points A and B, 1,000 meters apart, are plotted on a straight highway. So straight highway running east and west. No? From A, the bearing of the tower C is 32 degrees west of north, and then from B, the bearing of C is 26 degrees north of east. Approximate the shortest distance of the tower C to the highway. So we can already assume that tower C is not along the highway, but points N, A, and B are on the highway. Okay, so we can say that it's running east and west. So it should be from east going to west. So that is from right to left. Okay, so right to left. So that's from right going to left. Okay, and then let's say that this is tower. So therefore we can say that this is A, and then this is B, and then we can say that the tower is somewhere here. Okay, so this is C. And so this is um not necessarily a 3D, but this is only the grounds of the tower. Okay, the foot the foot of the towers. Okay, so we'll be able to make a triangle going here, and then another triangle going here. Okay, the bearing, so from A, the bearing of the tower C is 32 west of north. Okay, 32 west of north. So we can say that this one is the west of north. Okay, west of north. So this is 32 degrees. That's west of north. Okay, therefore if that is 32, of course this whole angle is 90, right? So that is 58. So this will become 58. Okay, and then the next one, the bearing of the tower C from no, sorry, from B, the bearing of C is 26 north of east. Okay, so east going north, so this will become 26. Okay, now we are asked to find approximate the shortest distance of the tower C to the highway. Now if you are looking for the shortest distance, it is always, okay, it is always the straight line. It is always a straight line. So from C, this is the highway, right? um this is the highway. The shortest distance for that is, of course, it's not this one. As you can see, that's longer, and then it's not also this one or anything like that. So it's not also this one. It should be the straight line. So you just have to make a straight line from there. Okay, so if that is a straight line, therefore we can conclude, if that is a straight line, we can conclude that this is a right angle, and this is also a right angle. Okay, so those are right angle. And then we also have points A and B 1000 meters apart. So therefore we can say that this part, okay, this to here is 1000 meters. And then we can also say, I'll just delete the word highway here because no longer needed. We can also say that we'll just introduce a new variable. So let's say that this is x and then this is y. Therefore we can say that x plus y is just equal to 1000. Okay, now using this, I'll just introduce another variable here. That is h. Okay, this line will be h. So using the line, how about this point will, let's say this is D. Okay, that is D. Okay, so using triangle DAC, using triangle DAC, you can have there, that's tangent, right? That's tangent 58 is equal to h over y, right? And then from triangle DBC, you can have tangent also. Tangent 26 is equal to h over x. H over x. Next, let's try to find, let's isolate values of x and y. So from here, we'll have y is equal to h over tangent 58. And then from here, we'll have x is equal to h over tangent 26. And then all you have to do is just substitute the value of x and y to this equation. Okay. So you'll have here again x plus y is equal to 1000, and then the value of x is equal to h over tangent 26 plus value of y is h tangent 58 is equal to 1000, and then we will be able to solve for h. Now if you will be able to solve for h, the value for that is just 373 373.8076 meters. So this will be the answer. Okay, so let's move on to the next problem. Okay, so we got our next problem. So we got two stones are 1 mile apart and are of the same level as the foot of the hill. So the angle of depression of the two stones viewer from the top of the hill are 5 degrees and 15 degrees respectively. Okay. So let's try to draw the figure again. So we got the top of the hill. Oh no, the hill. This is the height of the hill. And then I think we can have another one here. And then this will be the ground where the stones are located. And then two stones are 1 mile apart and are of the same level. So the angles of depression, so it looks something like this. Okay, and then we got another one here. Here we go. Okay, so let's put all the labels that we can. So let's say that two stones are 1 mile apart. So let's say that this is the stone 1 and then stone 2. Therefore, this is 1 mile. What do we have? What given do we have? Off the top of there is 5 degrees, right? 5 degrees. 5 and 15. Okay, so this will become 15. Okay, 15. So this is your hill. Okay, this is, let's say that this is h. Okay, so this is the top of the hill. No, actually it's angle of depression. Forgot about it. It's angle of depression. So this should be not here. This should be I am quite confused how to write these ones, but we got a line here, and then that is 15 degrees. So should be here. Okay, so this is 15, and then we got another one. No, should be here. So this is 15. Yeah, so this is 15, and then this is only 5. Yeah, okay. So that's what we do. Let's say, let's make another variable here, which is x. Let's introduce another variable. So you'll have here, if this is 15, we can also say that this is 15, right? And then if this is 5, that is 5. Therefore, we can also say that this is 5 degrees. So you'll have here for the first triangle, this the smaller triangle, the one with the 15 degrees. So we can have their tangent, right? The tangent 15 is equal to h over x, and then the larger triangle can have their tangent 5 is equal to h over 1 plus x. Okay, so we can find the value of h and x actually, but we only need h. So with that, you can just use your own method. So we got two equations, two unknowns, that's h and x, and we got two equations. So what you can do is substitute the value of h here to here, or value of x to here, or something like that. Or maybe you can from here we can just isolate x. So x is equal to h over tangent 15, right? And then this one, substitute it here. So you'll have your tangent 5 is equal to h over 1 plus h over tangent 15. Okay? So if you find the value of h here, the h will be, or h or the height of the hill is 0.3. So we got 0.3 mile. So this will be your answer. Okay, so let's get to the next problem. Okay, so we got our next problem and the last problem for this topic. We have three circles of radii 3, 4, and 5 inches respectively are tangent to each other. So I already draw it. External, they are tangent to each other externally. So find the largest of the triangle performed by joining the centers. Okay, so let's say that we have, this is the center, center, then center. So we have to make, so by joining the centers, so we have a line here, then a line here, then line. So we got here the triangle. Now we got radii of 3, 4, 5. Okay, so we got here r of this triangle is 3, and then r of this one is equal to 4, and then r of this one is 5. So as you can see from this one, this this and this line is a radius, right? And then these are also radius, and these are also radius. Therefore we can say that this is 3, 3, and then this is 5, 5, and then 4, 4. So if I will isolate that triangle, you'll have something like this. So we got 4 and 3 here, and then we got 5 and 3 here, and then we got 5 and 4 here. So isolating again the triangle and adding the sides, you'll have a triangle which is 7, 8, and 9. Okay, so we are looking for what? Largest angle. So largest angle. Okay, so let's say that this is angle B, this is angle A, and this is angle C. So the largest angle formed by that, of course you'll have angle ABC, right? So the largest angle, you can try it out. Okay, if you can try it out, you can just solve ABC. You can solve ABC and then just answer the largest one. But most of the time, the largest angle formed by those three sides is the opposite angle of the longest side. Okay, so that will be angle B. The longest side is 9. The opposite angle of 9 is B. So you can solve for angle B. So let's solve that using cosine law. Let's just use cosine law. The not actually the shortcut, but the easy the longest side is 9, right? So all you have to do is just add the square of the two sides and then minus um, the longest side, and then that's 2a, 2 times the two sides, 2a times 7. There you go. Okay. So if you solve this just came from the cosine law, okay? So if you solve this, you'll have 73.3985 degrees. If you solve the other two, you'll have 48 degrees and another 58 and another one which is 58 degrees. Of course, the longest one is 73 degrees. Okay? So let's go to the next topic.